Alright, so I'm making this video here to address two super good questions that came to me. The first question was that I know how to make a tree diagram and an area model, but how do I know that I'm setting up correctly? Or how could I find a method so I set it up correctly every time? Alright, and that's going to really rely on figuring out what are my events, how many events do I have, and what are the outcomes of these events. And then the second question that came in was talking about how do we use that addition rule that came in lesson 424. And I'm going to address those both here with two questions talking about the probability, and then one question at the end talking about the addition rule that we learned. All right. And like I said, when we're addressing a question like this and we're trying to figure out how do I set this up correctly, I need to think what are my events and what are my possible outcomes of each event. And so we're going to look at this problem here. And it's saying for fun, we're deciding to flip three different coins. We flip the first coin, the second coin, then the third coin, and we're looking for the probability that we land on heads on each coin flip. Okay, so the first thing I'm doing is I'm looking at this problem and I'm deciphering how many events are there. Well, we're flipping the first coin, that's event 1. We flip the second coin, that's event 2. And then we flip the third coin, that would be event number 3. Now, anytime you have more than 2 events, we're going to need to use the tree diagram. Okay, because we can do 3 branches, we can't do 3 sides of an area model. And so we're going to look at this one first with the tree diagram. And now I'm looking at this first event because that's going to dictate what my first branches are. So I'm thinking, what is going to be the outcomes, the possible outcomes of my first event? Well, if we're talking about flipping a coin, there's going to be 2 possible outcomes. It's either going to be heads or it's going to be tails. Okay, so that's my first event. Heads or tails. Now my second event is going to branch off the first one, and again I'm thinking what are my possible outcomes of the second event? Well, the second event again is a coin flip, and so it has 2 possible outcomes. It's either going to be heads or tails, or heads or tails. Okay? Now we go into the third event and we think again, what are the possible outcomes? And again, it's a coin flip. And so we branch one last time and we say, well, it's either going to be heads or tails, heads, tails. And I'm branching off that second event, and that is why I have so many different ones here. Okay. Now each one, this one's not too bad because it's a coin flip. There is 2 possible sides of a coin. One is heads, one is tails. So we say there's a 1 in 2 chance of getting a heads, a 1 in 2 chance of getting a tails. Same thing goes for each of them because there's always every time we're flipping a coin, there's 2 possible outcomes, heads or tails, and one is going to be heads, one is going to be tails. So I'm labeling each branch with a 1/2, and I could do that down here too, but to save the space, I'm just going to put dots and say that they are the same as the ones previous. Now, if I'm looking for the probability of getting 3 heads, that's this branch, and this branch here. That's the 3 heads in a row. Okay. Now that would be the probabilities of 1/2 times 1/2 times 1/2, which would give me a total probability of 1/8. 1 in 8 chance that I would get all 3 heads in 3 coin tosses. Okay, so the big thing again to highlight is that all I'm doing is I'm looking, okay, first event, what are the possible outcomes? And we said in this case, it was either going to be heads or tails. Then I'm thinking second event, what are the possible outcomes? Again, because it's coin flips, heads or tails. Third event, I'm thinking, what are the possible outcomes? It's going to be heads or tails. Let's see another example that's a little bit more involved and that we can use the area model on. So here we have a problem that says you get home from the grocery store and you have 2 bags of full groceries. The first bag has 4 jars of peanut butter, 2 containers of blueberries, and 6 apples. The second bag has a bag of rice, 6 containers of strawberries, and 2 containers of salad greens. What is the probability that you pick a jar of peanut butter and a container of strawberries? Well, there's 2 events happening here, okay, because we're going to be picking out of the first bag, that's going to be my first event, and then we're picking out of the second bag, that's my second event. So 2 events, I can use the area model here. Okay, so I'm going to set it up as a square or a rectangle. I'm using a square here. Okay, and the first event's going on the left, second event's going on the top. Again, just like I did in the tree diagram, I'm thinking, what are the possible outcomes of the first event? Well, the first event is picking out of the first bag. Okay, and so I'm either going to be getting a jar of peanut butter, that's one possible outcome. I'm going to be getting a container of blueberries, that's another possible outcome, or I'm going to get an apple. Those are my 3 different outcomes here. Okay, the second event, what are the outcomes? You could either get a bag of rice, a container of strawberries, or a container of salad greens. And I'm going to split up my chart like so. Now that I have it set up saying, okay, these are the outcomes of event 1, these are the outcomes of event 2, I can start thinking about the probabilities of each outcome happening. And so I'm thinking, okay, how many possible outcomes are there, or how many possible items are there in bag 1? So 4 jars of peanut butter, 2 containers of blueberries, and 6 apples. That's 12 items in the bag, and 4 of them are peanut butter. Again, since it's still event 1, there is 12 items in the bag, and 2 of them are blueberries. And similarly, there's 12 items, and 6 of them are apples. Okay? Going to do the same thing kind of in event 2 here. Still thinking, okay, what is the total number of items in the bag? So there's 1 bag of rice, 6 containers of strawberries, and 2 containers of salad greens. That's 9 total items. Only 1 of them is a bag of rice. So 1 out of 9 is a bag of rice. 6 out of 9 is a container of strawberries, and 2 out of 9 is a container of salad greens. So that's how I'm setting this up. So setting up, okay, what are my possible outcomes, and then what is the probability that that outcome actually happens? I'm looking for in this problem the possibility that you would get a jar of peanut butter and a thing of strawberries, and that would be this box right here. So that would be 4/12 times 6/9, which, if I multiply them correctly here, 6 times 4 would be 24, and 9 times 12 is 108. And so I could put that in here, I could reduce it down, but I'm going to put it in here as it is. 24 out of 108 is my probability of getting the peanut butter and then the strawberries. Okay, so I know the question really focused on setting it up, and I hope this clears up how I'm setting up my first event and my second event and the numbers that go with them, and how they differ a little bit between the 2 events happening in this problem versus the 3 events happening in this problem. I'm going to go quickly now to the addition rule. Okay, the addition rule is written weird. I don't really like that I included intersections in the title, all right, because really the addition rule is talking about how we can find the probability of the union by using this rule here. And what they're saying is if we add the probabilities of both and then subtract out the intersection, the probability of the intersection hitting, then we'll be able to find the probability of the union. And so we're going to hop back to this problem here to see that. So I had my betters chip on 13, 14, 15, 16, 17, and on the reds. And I have these sample spaces written out here. So I have the first sample space here, 13, 14, 15, 16, 17, 18, and then my second one here with all the reds. Now, I have my union already written out below that. And remember what a union is, it's the probability of one or the other hitting. And so I contain all the possible answers or all the possible numbers that one or the other bet will hit. Okay? And pretty much all that happens is I combine these 2 sets and I don't let numbers repeat. That's how I can explain the union. You combine the 2 sets, but you don't let numbers repeat. All right? And we talked about earlier in this lesson that there was 38 possible outcomes on a roulette board. Well, if I want to talk about the probability of this specific union hitting, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21 out of the 38 possible numbers are covered here. And so my probability would be 21 out of 38. Now, using the addition rule, we can do this without needing to make this big list for the union. Okay? What we can do is we can say, okay, what's the probability of the first event hitting? So that's 1, 2, 3, 4, 5, 6 numbers. So 6 out of 38 would be my probability of the first one hitting. So that would be like PA. Now we're talking about PB, the probability of the second event here, PB. And so we have, in my second one, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And so that is 18 out of 38 options. And then we're going to subtract out the intersection. We're going to subtract out the overlap here. And so I want to think about what numbers are overlapping in each one. And so if I'm going through my list here, 14 overlaps, 16 overlaps, and 18 overlaps. So that's 3 out of 38 that are overlapping, that are in the intersection of these two. Now if I do this here, if I do my adding here, I get 6 plus 18, that's 24, minus the 3 from the intersection, that would be 21 out of 38 options. Okay, so I'm just adding my probability of the first 6 out of 38, to the second one, which is 18 out of 38, and then I'm subtracting out the 3 because there was 3 numbers that were repeated in both sets here. And I said those numbers again were 14, 16, and 18. And when I do this, use this addition rule right, I'm finding the probability of the union that I found when I wrote it out as a big long list. Okay, so that's how we can use that addition rule to kind of shorten our amount of work instead of always having to create these big lists and say, okay, I have this many numbers out of all my possible outcomes. Okay, I hope the video is helpful. If you have more questions, if you want to see another example of the addition rule or setting up a tree diagram area model, always just let me know. As we approach the end of Chapter 4 here, it's good to reach out and get some of these clearing questions out of the way so that we feel more prepared when that test comes around.